blood pressure for all Americans, I'm going to call it equal to, I'm going to just use a round number, 100. Okay, and the standard deviation for blood pressure in the population in general is 10. Now, I'm going to test a certain population, say diabetics. The mean blood pressure for diabetics, okay, I want to prove that it's different than it is for the entire population. Well, I'm not going to be able to measure every diabetic. Okay, there might have been very large studies that have a pretty good idea what the standard deviation for the population, what the population average blood pressure is. But for my study, I'm not going to be able to measure all diabetics in the country. I'm only going to be able to sample, say, 100 or 200 or 500. The more that I sample, the harder it is going to be that I need to sample, the harder it's going to be to justify this study because it's going to be very expensive to do. So I want to know what sample size, the minimum sample size I need to use in order to do this. So let's say I've done like a kind of a preliminary survey, and I think that the average blood pressure for my diabetics, my population of diabetics, is roughly 95. Okay, so now I have to say to myself, okay, I'm going to the internal review board, and I'm going to tell them that I think, based on some survey data, some other papers I've read, I think that I'm going to make that 105, make it higher rather than lower. Makes a little bit more sense that way, right? Okay, I'm going to say to the review board, I can do this study. I want to demonstrate that blood pressure among diabetics is higher than general population, and I can do this study economically. I only need a sample size of N. So now we have to justify what that sample size is going to be that I need if this is really true. So I'm going to start off with the assumption that the population, the variability, a standard deviation for the population I know to be 10. I'm going to say that the standard deviation for my diabetics is also 10. I'm going to assume that they're the same, the variability. Even though the mean's different, the variability is the same anyway. That's probably not a bad bet. Okay, so now I have to say to myself, well, I'm gonna have to find the mean value for my sample that I take. And that mean value for that sample, I'm gonna calculate a confidence interval. And if that confidence interval does not include 100, I can say that the diabetics have a different blood pressure, average blood pressure, than the rest of the population. So I need a confidence interval that goes from 100 to something larger. Well, since my middle value I think is going to be 105, I need a confidence interval that goes from 100 to 110, right? If I think my mean is 105, I need a confidence interval that goes no more than from 100 and no higher than 110, because my mean is always going to be in the middle of my confidence. My mean for that sample is going to be in the middle of my confidence interval. So that's the minimum amount that's the widest confidence interval that I can tolerate and still say that these two values are not equal to each other. Okay, everybody see why I did that? Okay, I got to make sure that's not the case. So what's my margin of error got to be? My margin of error has to be 5, right? I can't tolerate a margin of error bigger than 5, because if it does turn out that the mean for the diabetics is 105, if my margin of error is 6, then my confidence interval is 99 to 111. And 100 is within that confidence interval. So I can't say that the mean for this group and the mean for this group are different. But if my confidence interval is 5 point, if my confidence interval is 4.9999, or basically 5, then I'm always going to be over 100, 100.1 to 100 to 109.9, right? 109.9. Yeah, as long as my confidence interval does not include 100, I can say that these two I'm 95% sure, or have less than 5% chance of being wrong, if I say that these two population means are different from one another. Okay, so I need a margin of error of 5 here. So if I go back here, my sample size has to be equal to z for alpha over 2 times my standard deviation divided by my sample size and square that whole value. So if I do this, it's going to be 1.96 for 95% confidence interval times a standard deviation of 10. Oh, I'm sorry. This is the error in my margin of error divided by my margin of error, which is 5. Okay, so let's see what that comes out to be. That's 1.96 times 10 divided by 5. Okay, that's going to be 4 squared. It's going to be equal to 15.95. Okay, well, if you come out to an answer like 15.95, you can't have 15.95 subjects, so you always round up. So I need a sample size of 16 or larger to have a shot at demonstrating that if the true population mean is 5, true population mean is 105 for my diabetics, have a shot at actually proving that with a 95% confidence interval. Okay, so what happens if my standard deviation is let's see, what happens if my let's see, what happens if my standard deviation is larger than 10? Let's say it's 20. Well, if it's 20 instead of 10, then this becomes 1.96 times 4. 5 into 20 is 4. That's 2 times 4 is 8. Squared is 64. I need a sample size of 64, right? Well, what happens if these two values are closer to one another? In other words, instead of 105, instead of population mean is 100, and I think that diabetics are really 102, and I want to prove that they're different. Well, my margin of error now is only 2. So this number down here becomes 2. Let's say we're back at a standard deviation of 10. So 2 into 10 is 5 times 2 is 25. 25 squared is 6. My sample size then has to be 625, right? So the sample size, standard deviation, and our margin of error all combine to determine what your sample size has to be. Okay, so using this formula, presumably in a problem, let's just take a quick look to see what that problem looks like. Okay, because I think that, was there one in the practice? I think there was one in the practice. Let's see if it's there. See if I can find it quickly. Medical school, 30%. Test. Yeah, wait, it's test the claim. State the conclusion. Confidence wider. But I don't see another example in there for sample size. But I think pretty much that's what a problem would look at. That's kind of information that you would expect to find in a problem like that. Okay, so I think probably a good time to call it quits for now. When we get together on Saturday morning, I'm going to try and make sure that this stuff is hopefully recorded and that I can post it. When we get together on Saturday morning, we're going to cover hypothesis testing, null and alternative hypothesis. We're going to cover single sample t-tests and t-tests for proportions. And we're going to look at the various kinds of t-tests that you can use for independent and paired samples. Okay, so our main focus on Saturday is going to be hypothesis testing and the t-test, including independent samples, paired samples, and single sample t-tests and proportions. Okay, so we'll have plenty to cover then, and we'll actually go over a few examples of using SPSS to solve those problems, because it's likely that there'll be a couple of problems on the test that involve that. Okay, so we'll get some exercise on doing that. All right, so hopefully that helped out. If you got questions on this, I'll put, like I said, I'll try and make sure this gets posted so you can go through it again. If you have questions on it, send me an email. So like when we get, I can either reply to you directly, or when we get together on Saturday morning, or if you wind up watching the recording of this on Saturday morning, that I get an opportunity to address any questions that you have.